Okay, calculus, it looks like we are finishing up here. This is AB 28. We're talking about the accumulation, the buildup, meltdown, increase, decrease part of area. But this is part 3. We're looking at example 2. So let's get it done. We've kind of done this once or twice here. Now we're just kind of working our way through the example, just more exercise with it. Alright, so let's talk about this first one. F, capital F, of 0. That means the integral from 0 to 0 of little f of t. And that has 0 width. Notice that we go from 0 to 0, so we are here, and then from here to nowhere. So that is equal to 0, because 0 width times no matter what the height is not going to work at all. Alright, now let's look at f of 2. That's really the integral from 0 to 2 of little f. And that would be right here, this first mark at 2. So we're talking a quarter circle, and this quarter circle has a radius of 2. And if the radius of 2, the full circle, the circle would be pi r squared, like we've said before, pi r squared, which is going to be pi times 2 squared, and that's 4 pi. But in this case, if the circle is just a quarter circle, it's going to be 1/4 of that. 1/4 of that pi, 4 pi, is just pi. Okay, so that means this here we got plus pi working with us, so that's just pi. Now if we're going all the way to 4 out to here, we're going to add another quarter circle on there, which we just figured out was pi, and then we're adding even more. Remember, we're starting at 0. The start right here is 0. This is our start. So when we're measuring left or right, we're going to start from 0. So if our number is bigger than 0, we're moving to the right. If it's less than 0, we're moving to the left. Okay, so what's going to happen next then? So now we're going all the way to 6. So now when we go to 6, this is a little bit different because if I'm trying to consider what this area would be, now it's going down as well as to the right, and to the right is positive, but down is negative. So a positive width times a negative height, that's going to give me a negative value. So we know it's going to be negative, but now let's see what the value would be in general. So f of 6, the integral from 0 to 6. Oh, actually we got to add some stuff up here. The second one, f of 4, this is the integral from 0 to 4 of little f of t dt, is 2 pi, because it's pi plus pi. But now from 0 to 6, we're going to have a subtraction thrown into the mix because we have a triangle that's 2 wide by 2 tall, so that's forward, half of that is 2, so it's negative 2. So now the total from 0 to 6 is going to be pi plus pi, and then we got minus 2. Or 2 pi minus 2 if we were to kind of summarize that. Okay, so now let's take that information and we're going to go a little further with that. So I'm going to take a snapshot of this. So let's clipboard that. We'll go to the next page here. I'm going to paste it to this page because we've already done some work, but we want to see some more values in here. Okay, f of negative 1. So now here's where it gets interesting. Now we're moving left, so that's a negative. But we're also moving up, which is positive. So now we're thinking negative to the left, but positive going up. So that total area in there is actually going to be negative. So this is a negative number here. Well, we got a height of 2 and a width of negative 1, because we're moving to the left. And it's a triangle, so we got to half it. So that's going to be 1 times 2 divided by 2, or negative 1. As we continue in this, it's kind of weird because now as we're going to this area, whenever we go to out to negative 2, so f of negative 2 is what we've got. The first one was negative 1. So now we're doing from 0 to negative 2. So we're moving left again. We're going to take that negative 1, but then we're going to add another couple of boxes on here, negative 1 and negative 1. Because this is just a rectangle. It's a 1 by 2 rectangle. 1 across the bottom here and 2 going up and down. So that means that we have our original area, which is negative 1. And then we're going to add some more to that, some more negative. And we got 2 more negatives. Total equals negative 3. Okay, f of negative 3. This is where it gets a little bit interesting because notice we have this triangle here that I'm just now outlining. And the area of that triangle is going to be a half times 2, which is 1. And then we split it in half. So that's negative half for this triangle. But now for this other piece that's below, we got negative 1/2 this way, and we also got negative 2 going down, and because there's 2 negatives there, that's going to give us a positive product. So this time it's going to be plus 1/2. So the area just between 2 and 3 is actually 0 because we got 2 pieces that are countering each other. So the area for f of negative 3 from 0 to negative 3 is going to be, the first 2 that we found. It's that, whoops, wrong one. It's the, here we go. It's going to be the negative 1, then we got the minus 2, and then we got minus 1/2, but then we're also going to have plus 1/2, and those cancel each other out. They make a 0. So again, our answer is actually negative 3. All right. F of negative 4. So now we're going all the way out here to negative 4. Which means we got more blue area because we are moving left, which is negative, but we're also moving down, which is also negative. So this last area here is going to be a 1/2 triangle, so that's going to be a plus 1. So now we have accumulated negative 1 minus 2. We got the 1/2s cancel each other, and then the final piece there is the plus 1. Altogether, that equals negative 2. So f of 4 equals negative 2. Now is where we start getting a little bit interesting with the capital F prime. Remember that capital F prime is the same thing as little f. So this is like asking us what's f of 4. Well, f of 4 is just a y value. It's like a vertical value. And so we look at our graph and we say, okay, here we are at 4. Let's color code these a little bit. Let's use some olive green. So f of 4 is right here, and that's at negative 2. So let's do the next one. Capital F prime is the same as little f. So little f of 2 is up here, and that's at positive 2. Capital F prime of 6, or little f of 6, is going to be, oh, you know what? I totally did this wrong. This is negative 2. You guys are probably checking this out. At 4, we are not at negative 2. We're at 0. So let's erase that. This equals 0. What about f prime of negative 3? Okay, f prime of negative 3 means we are all the way out here, which means we're down there. So capital F prime of negative 3 is the same as little f of negative 3, which is negative 2, just like k. All right, do we got more going on here? I think we might have a little more. No, we don't. Now we're going to start talking about areas increasing and decreasing. Okay, so let's talk about increasing. Where is f increasing? It might help if we kind of summarize our results a little bit in a table. I think that would be great. So I'm going to add in a little table here underneath. We got marks here all the way out to negative 4, negative 3, negative 2, negative 1, and then we go 0, 1, 2, 3, 4, 5, 6. Okay, so I'm going to have capital F, we have X, and then we're going to do maybe capital F prime, also known as little f. All right, I'm going to cheat now. I'm going to throw in some flat lines that help me. If you have a ruler, some spare paper, maybe this would be really helpful. Okay, so there's one flat line. Whoops, let's do this one. There we go. And the last one here on the bottom. Didn't really need that last one, but it's fine. Okay, so we got negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Alright, so there we go. So I don't really need this extra here. Let's just shrink it back down. Shrink it back down. Shrink it back down. Okay, so let's fill in my numbers. We're talking -4, -3, -2, 1, 0, 1, 2, 3, 4, 5, 6. Okay, a couple of things I want you guys to notice. We never even did 1 or 3. That's because it's in the middle of a curve, and it's awkward to calculate that geometrical area. So we're going to skip 1 and 3 for now, at least for the f. We might use it for the f prime. But we'll see how that kind of comes into play. And similarly, we didn't do 5 either. So let's cancel that. So we did 0 to 0. That's just 0. And what's little f of 0? It's also 0. That's kind of cool. Remember that capital F prime is the same as little f. Same thing. What about at 6? That was at -2 down here. But what was the total area at f of 6? That was 2 minus 2 pi. Okay. And what about at 4? Okay, at 4, we had, what did we have? At 4, we were at 0 for little f. But we had 2 pi by this point. And at 2, we had just pi. And this was at 2. At -1, we had an area. This was actually a positive, no, a negative. It was a negative area. So that was -1. And but if we look at it, it's kind of above the x-axis. That was kind of interesting. So it's above the x-axis at 2. That's a positive number. Okay, and then here at -2, we had a value of -3, and we were still above the x-axis at 2. At -3, we were still at -3, but this time we were down here at -2, it looked like. And then at 4, we were at 0, and this was back at -2. Right, so we're looking at when do we decrease, when do we increase. So let's do some math here. When we go from 0 to -2, that means that we are definitely decreasing to here, but then right up until about 3.5 is where that switches over, and then it's going to switch to blue. Now we're increasing. We were at -3, and from -3.5 all the way up until 0, we increase because we're at -3, -3, -1, and then 0. So the numbers are getting bigger. And then we increase even more, all the way up until we get to 2 pi. And then we hit that 0. And after 0, it looks like we are going to decrease. So here we got decrease on the outsides, but we are increasing the entire time on the inside. This is a little bit backwards because the one previous to this, I think it was one previous to this, maybe even more earlier than that, but we didn't start in the middle, so we only moved to the right. But now we got both sides to consider. You know, what happens when you accumulate in a negative direction or in a positive direction? Then it's almost like your snow melt kind of flip-flops. Your top's above the x-axis, like for example here, it winds up being kind of an increasing region where the other one is decreasing. That's reverse from the other values we got. That's kind of an interesting thing to consider. So on what subintervals are we increasing and decreasing? So remember that capital F increasing means capital F prime is greater than 0, which also means that little f is greater than 0 for the most part here. So when is that true? Well, that is true from -3.5 all the way up until 4. Now for the other part, for capital F decreasing, which is capital F prime less than 0, or little f less than 0, that's happening on two intervals. It's from negative 4 to, oh, this should be negative 2.5, pardon me. Negative 4 to negative 2.5. And also from 4 to 6. All right, where does f achieve its minimum value? So remember, minimum is when we change from decreasing to increasing. And is there any time when that happens? And there is actually, right here at negative 2.5, because we were decreasing before it, and we were increasing after it. So I need to figure out what's capital F of negative 2.5. I do have to figure that out. But then I also have to compare the endpoints, which would be f of negative 4 and capital F of 6 as well. I know these two, so let's go ahead and calculate or recall what those were. Capital F of negative 4 was negative 2, and capital F of 6 was 2 minus 2 pi. No, wait, the other way around. 2 pi minus 2. So if I were to just approximate this bottom one, 2 pi is about 2 times 3.14. That's a really gross approximation there, but that's 6.28 approximately. Subtract 2, and we're at about 4.28. So we're at a positive number. So that's out. And f of negative 4, maybe. But what's f of negative 2.5? Well, f of negative 2.5 would be these three negatives here, here, and here, those three added, plus this other negative 1/2. So how much would that give us? That would give us negative 3.5. So this is going to total up to negative 3.5. And that is the maximum, or minimum, pardon me. Whoa, wrong value. So where is the minimum value? At negative 2.5. What is it? Negative 3.5. I feel like I'm chanting out at some protest. Who are we? What do we want? It's saying, where is it? What is it? All right, let's talk about the other side. Maximum. Please notice this says, what is the minimum value? I think you could probably infer something here. This should say, what is the maximum value? All right, so maximum value happens when we change from increasing to decreasing. And that happens at 4. So we know that before f of 4, or before x equals 4, we were increasing, and after we were decreasing. So what's f of 4? Well, that was 2 pi. We did figure that out. But then we got to compare endpoints. Remember that f of negative 4 is negative 2. Well, that's nowhere even close to a positive number. And then we have f of the other endpoint, which is 6, and that was 2 pi minus 2. And we know that can't be it because it's less than 2 pi for sure, without even having to do a gross approximation. So the answer is where in the interval? At 4. And what is it? 2 pi. All right, now let's start to look a little bit at concavity. Concave up. Okay, concave up, f concave up means that capital F double prime is greater than 0, which means that little f prime is greater than 0. So what does this mean? This means that our line has a positive slope. So that's what we're really looking for. Similarly, for concave down, we're talking capital F double prime less than 0 and little f prime less than 0, which means we have a negative slope. So let's hop on that. Or we could say this is decreasing. Little f is decreasing. Little f is increasing. So on what interval is it concave up? Let's check that out. When is it concave up? It looks like it's concave up from here to here, because we got positive slope. We're also concave up here from 0 to 2. Now for the other ones, I should use probably a different color here. Let's do purple. So purple, I'm going to color the negative slopes in purple. So those purple zones are from -4 to -3, from -1 to 0, and from 2 to 6. Okay, so we got to write those things in. So when are we concave down? All this is probably written in purple here. Okay, so concave down was from -4 to -3. Also from -1 to 0, and finally from 2 to 6. When were we concave up? Well, that happened between -3 and -2. And it also happened from 0 to 2. Now, how do I know this? And a lot of it is based on knowing the slopes of little f. Because when little f is decreasing, that means that the slope is negative, which means that capital F is capital F double prime is less than 0. So that means we would have a negative concavity as well. All right, last one. Where do we have points of inflection? Okay, so remember, a point of inflection happens when there's a change in concavity, which is the same as saying change in sign of F double prime, which is the same as saying change in slope of F, or change in sign of F, little f, single prime. So when does that happen? Well, if we take a look at our picture again, when do we switch from decreasing to increasing, or the other way around? Looks like it happens here at 3, and it happens here at 2, and that's it. Now, a lot of you might be thinking, well, what about this area, this zone in here? We're going to see how that looks in a second. But between -3 and 2, it's not a point of inflection. It's not narrowed down to an individual point. It's a whole region. So that doesn't really count. So we have a point of inflection at x equals, what does x equal? -3, and x equals 2. So we got 2 of them. So now I think we need to graph this. Ooh boy. Quick note, each tick mark on the y-axis is 2 units. So that means we're going 2, 4, 6, 8, and similarly this goes down to -8. So let's sketch the function of f. Good thing we made a table earlier, didn't we? Yes, we did. It's down here at the bottom of this page. So starting at -4, going to 0, it's going to be -2, -3, -3, -1, 0. -2, -3, -3, -1, 0. Now we didn't really have anything at 1, but we know that at 2 we're at pi, which is a little bit more than 3, so we're talking about here. And then 2 pi, which is going to be double that, at 4, it's going to be just above 6, so probably about there. And then we subtract 2 from that by the time we get all the way out to 6, so we got to drop down to about 4, just above 4, like literally just above 4. Okay, so now we got some interesting things in concavity, and the thing that I found the most interesting is between -2 and -1. Remember, that was a 0 concavity. What do I mean by that? Right here, there is 0 concavity, which means no bend. What kind of lines don't have bend in them? Linear. straight. Not necessarily flat, but they are exactly straight. So let's make a line that's exactly straight, like this. No bend. Okay, now we know that we actually hit our lowest value between 3 and -3 and -2. So we are going to hit the low value right in here. And we also switch concavity at -3. So instead of being concave up like that, we're going to now start leveling out the other way. All right, and we do have a change in concavity as well from -1 to 0. It is a negative concavity, so I am going to flatten this out. And then from 0 to 2, we have a positive concavity. Let's take that back a little bit here. There we go. And then from 2 to 4, we have a negative concavity. And from 4 to 6, we still have a negative concavity. So there's our line. That's it. Check. Done. Happy. Move on. Okay, remember to really go back and look at the things. I use just concavity, but we can also look at this as increasing, decreasing. To make the sketch, we also looked at the individual points, which were kind of rough because pi is an approximation here, where we're not talking about the exact value of pi. That would be impossible to draw by hand. Okay, so that's what we got. This is the end of part 3. Hopefully you guys do well. Wait, is this the end? Yes, it is, because there's nothing on these empty pages. Have a good night, and see you in class.